Okay, let's get started. My name is Mike Niehaus. I'm a Senior Product Marketing Manager for Microsoft, working in the Windows division. In today's session, we want to talk about the Assessment and Deployment Kit and all of the tools in it, which is one of those things where someone volunteered me to do this session and said, well, how would you like to do a session about the ADK? Okay, great. What am I supposed to do? Demo all the tools. All of them? So we've got 75 minutes to go through 19 tools that exist in the Assessment and Deployment Kit. So we're going to be focused pretty much on demos for most of this session to go through and show you what each of those looks like. It's almost like someone bet me that we couldn't get through 19 tools in a 75-minute session, but I think we can do it. We'll try our best to get through it. To first start off, we want to talk about really what is the Assessment and Deployment Kit. Look at a quick listing of all the different tools that are out there, and then let's start going through them one at a time. So first of all, the Assessment and Deployment Kit was released at the same time as Windows 8 and Windows Server 2012. It does replace the Windows Automated Installation Kit, so you can think about it as the latest version of the Windows AIK. It contains all of the same tools that were in the Windows AIK and then some. So rather than having a whole bunch of separate downloads for things like the App Compat Toolkit and Windows Performance Toolkit and other pieces, now all of those have been pulled together into the Assessment and Deployment Kit. There is a new installation process that goes along with this. So when you go out to the Microsoft Download Center and search for ADK, you'll find the adksetup.exe and download it and think, wow, that was quick, because it downloads in seconds, because all it really is a bootstrapper. This bootstrapper then allows you to check off which of the components you actually want for the ADK. It'll install the ones that you want, but in order to do that, it has to go back out to the download center and download those individual pieces. If you were to select everything, you would probably download well over a gigabyte worth of stuff. The biggest one is still Windows PE. Downloading the boot images are going to take a little bit of time, but depending on what you select, it'll tell you how big the download is going to be. If you have an environment that's not connected to the internet, you can run ADK setup from an internet-connected machine, tell it to download the components without installing them onto a computer, then copy all of those files to another machine, run ADK setup on that other machine, and it'll know to use the already downloaded files instead of going back out across the internet. This does include the x86 and x64 components, just like Windows AIK did. It doesn't include any ARM pieces. So if you're looking at customizing Windows RT or running any of these tools on Windows RT, you won't be able to because we don't ship the tools for Windows RT. Windows RT devices, which I'll talk about later in the week, are always shipped pre-configured with an operating system already on them, installed by the OEMs. There's no enterprise imaging capabilities that go along with that. So, as a result, we don't need deployment tools for ARM. We just need it for x86 and x64. There was the big rumors going into the Windows 8 timeframe that, we're not even going to ship x86 anymore. We're going to move everything to x64. But if anything, we've re-stressed the importance of x86 now that we have Atom-based tablets that are out in the field. Those Atom-based tablets are x86 only. So as a result, it's fairly likely now that you'll still need x86 even if you've moved all of your desktop and traditional laptop machines over to x64. So the kit itself can be installed on Windows 7. It can be installed on Windows Server 2012. Those make sense. It can also be installed on Windows 7 and Server 2008 R2. It's not supported on earlier versions of the operating system. So if you're still running Server 2003 or Server 2008, you would need to find a new server to install the ADK on that's running at least Windows 7 or Server 2008 R2. If you try to install this on a machine that has the Windows AIK on it, it will actually install side by side with the Windows AIK, but we don't recommend it. We don't really support it. There are some conflicts between the WIM filter drivers used to mount WIM images between the two versions, so you could have problems if you don't get things installed in the appropriate order. So it's just easier to say, don't put them on the same machine. Before installing the 80K, uninstall the Windows AIK, then install the 80K, and everything should be fine. So there are lots of tools. The tools you can choose, the tools that you see actually are going to be different based on whether you're running a client or a server operating system. So the first thing you'll see when you run the 80K setup is it asks you, do you want to install it, and if so, where? Or do you just want to download it? If so, where do you want to put the downloaded files? Then it will ask you what features you want to install. By default, if you're using something like the Microsoft Deployment Toolkit or the System Center Configuration Manager tools for doing OS deployment, you would need to select at least 3 of these. You would need to select Deployment Tools, Windows Pre-installation Environment, and the User State Migration Tool. 2 of those 3 will be selected by default. The third one, User State Migration Tool, won't be. You'll have to check that off in order for those tools to be able to pull in the necessary binaries from that. In the case of Config Manager, if you were to install the 80K without USMT, you'll get a warning when you try to install Config Manager 2012 SP1 telling you you don't have the USMT files, you need to add those. In the case of MDT, you would get an error farther down the line when you try to update your deployment share. So make sure you have at least those 3 components and then select any additional components that you might want on the computer. The list of components that you would get is actually going to be different between a client operating system and a server operating system. So the list that we're seeing here is what you would see on a server. If we were to run this on a client, the list changes just slightly. So instead of seeing the Windows Assessment Services on the server side, we would see Windows Assessment Services Client on the client side. And we will also see this Windows Assessment Toolkit on the client side, where you don't see that one at all on the server side. So depending on whether you install on the client or on the server, you'll get a different list of components. Unless you're dealing with the Windows Assessment part of the 80K, which is where the new assessment part of the name comes from, you don't really need to worry so much about that. But if you are going to use the Windows Assessment Toolkit, which is useful to run a variety of assessments against your Windows computers, that one you'll need to install the 80K on a client machine in order to install it. Windows Assessment Services, the broader suite, we'll talk about that at the end. That's the one tool that we won't demo here because really it's targeting the OEM space where they run a dedicated lab with a dedicated server, dedicated Active Directory, dedicated test equipment, where it pretty much takes over and pushes out operating systems to the machines, runs a whole bunch of assessments on those machines, reports all the data back to a central point, and produces reports to say, are your machines meeting the Windows 8 logo requirements? That can be useful in an enterprise environment, but it requires that same type of dedicated lab, so it's not nearly as popular as the other tools. So overall, we've got a few different categories of tools. We have the AppCompat Toolkit, which is now part of the 80K instead of a separate download. We have the core deployment tools. User State Migration Tool has been in the kit for a while, so it's still there. There's a new version of that released with Windows 8. The Volume Activation Management Tool is included in the 80K. Windows PE, Windows Performance Toolkit used to be a separate download, is now included in the 80K. And then the Windows Assessment Services and Toolkit that we were just talking about. So that's the set of tools that we need to go through. So for the rest of this session, we'll leave that set of PowerPoint slides behind, switch over to virtual machines, and start walking through each of the tools. Now, for my own sanity, so I could keep track of where we're at in this list of 19 tools, I have a small little PowerPoint sidebar which will show us which tool we're currently working on. As soon as I unlock my machine. So that'll keep track of where we're at as far as all the tools go. So first of all, we want to start off by talking about the Application Compatibility Toolkit. And the first tool that's in the AppCompat Toolkit is the Application Compatibility Manager. Now, this application compatibility manager is designed to collect inventory about your environment. So it can create inventory packages that you push out to all the computers, or at least some set of computers in your environment, and it feeds that inventory back to a central database. Once you have that in a central database, you can tell it to upload that to the Microsoft service. The Microsoft service in the cloud can then report back compatibility information about all the apps that were discovered in your environment, telling you, are they compatible with Windows 8? Are they compatible with Windows 7? Are they compatible with x86? Are they compatible with x64? From the perspective of Microsoft's own testing, from the OEM's assessment or the ISV's assessment, or even from the community side. If the community says that the application works reasonably well, then, well, maybe you don't want to focus so much on testing that application. You'll focus on the ones where the community's never heard of the app. Your own custom internal applications or less common apps. So the first thing that you would generally do with the App Compatibility Manager, the first time you run it, it will prompt you for the creation of a database. In this case, I've already created the database, but you just need a SQL Server install, because it's going to store all of this in SQL. That can be SQL Express, no problem with that. You then need to create a service, this log processing service. A log processing service reads the inventory files from a file share and stores them into the SQL database. So we need to create a folder to drop these into. We need to put the appropriate security on them, share it out, and then run through this wizard to configure the settings for the collector. So I've already done that. So I've already got on this machine, I've got an ACT database. I've got the service running as the local system account. It's reading from this ACT log share. So there's just a service waiting in the background for any log files to get dropped into that share. And when it sees them, it processes them to add that to the local inventory. So the next piece then would be to actually push out the collection of that inventory. To do that, we click on Collect, and we can double-click to add a new data collection package, which runs a wizard where we can say we want to create an inventory collection package, which I'll call MMS Collector. It knows to automatically drop the output, drop the inventory into the file share that we've already configured. If we wanted to, we could tag it so you could create multiple collection packages and be able to tell which one collected what inventory. In this case, I can leave that off. I'll create that, save it as an MSI file. So this MSI file isn't your traditional MSI. It's really just something that you can push out using Config Manager, using group policy, using a startup script, using email. You could email it to someone and tell them to double click on it. So there are various ways to deploy this thing, but because it's an MSI, it's just easy for all the different deployment tools to actually execute it. But it doesn't install anything. All it really does is run some custom actions to collect the inventory, write that inventory to the file share, and exit. So it's just a simple process to deploy then. In fact, I can manually run it on this computer just by finding the MSI, double-clicking on it. It'll ask for elevation so it can get the full inventory. It'll run for a little bit in the background, and as soon as it finishes, it will write its inventory into this ACT logs folder that I had created before. The service that's running in the background will periodically check that folder, see that there are new files in it, and go ahead and process them and add that data into the inventory. Depending on where it's at in its sleep cycle, we might see that happen or we might not, and it'll update the statistics here to show us when that's actually happened. So typically you would create that MSI once, you would push it out to some percentage of your computers, maybe 100% if you wanted the complete inventory of all the apps, maybe to just a sampling if you were happy to just get a sampling of the apps that were in your environment. Push it out, it writes all the log files back to that log, the service processes them, and then they end up in the inventory where you can analyze them. So when we look at the list of apps that have been collected from the 6 or 7 machines that I've run this on, we've got a list of 63 apps that it's found. And at that point, I can click on Send and Receive, which is what talks to the service in the cloud for Microsoft, where it downloads the compatibility information that we've collected related to those apps. We can see those here in the list. Hopefully the internet connection will work out okay here. So it bundles all of that up, sends it off to the server, downloads the equivalent compatibility details that go with those apps, and then the process is complete. Once that's done, we can see that in the case of something like Silverlight, the vendor, which in this case would be Microsoft, says that it's compatible with 32-bit and 64-bit Windows. There are community evaluations from 2 different customers saying that it works just fine. So depending on how much testing you want to do, you would focus on things like maybe an app that has no compatibility information. The vendor hasn't provided an assessment, no community assessment's been submitted, no user assessments have been submitted. So it just allows you to take a look at your inventory and figure out, well, where should I focus my time? I'm not going to focus my time on areas where it's fairly obvious that this application is going to work. It is going to point out in some cases where there are apps that don't work. So really it's going to be an exercise of going through these reports and trying to sift them into various buckets. It's not about trying to get 100% of these tested and verified. It's really more about going through these and taking advantage of some of the tagging that you can do in here, because you can take an application and apply a label to it. So maybe you want to put a label on it to say this is a critical app, and then start running reports on just the critical apps. Anything that's not critical, well, maybe you don't even really want to bother doing any testing on it. Instead, you could just wait and see, does it work? Did anyone call the help desk? And then reactively deal with any issues that might come up, rather than trying to test in advance. So the real value of this tool really is to try to build this into a process that you would use inside of your enterprise to do the application inventory, first of all, and then the compatibility testing to see, are my apps compatible with the new OS that I'm looking to deploy? If you've already deployed Windows 7 in your environment, you probably have gone through most of this already. In the case of Windows 8, the compatibility is extremely good between apps that run on Windows 7 will run on Windows 8 as well. So hopefully this won't be nearly as painful as what you've gone through in the past, say from Windows XP to Windows 7. So that's the App Compat Manager. Fairly easy, fairly simple to set up. Another piece then that's in the App Compat Toolkit is the Compatibility Administrator. And this one serves a completely different purpose. This one is all about fixing things. So if you have an app that's not working and you want to try to get it to work without upgrading it, without replacing it, without doing anything that costs money, you can use this tool to try to create a shim. And all of these shims are basically ways of altering the behavior of the application to make it work on the new operating system. So as an example here, we can see all the different types of shims that are available, all of these compatibility fixes. There are a lot of them. Any of these can be applied to any application to alter its behavior. So I happen to have an app here that doesn't behave well, and it's kind of our standard troubleshooting application. So I can say that I want to create a new compatibility database. And for that, I want to create a new application fix. And for that fix, I need to point to the app itself, which I have installed on this computer. It's the standard stock viewer application, which has lots of issues, but we'll try to fix one or more of those. I need to actually give it a name, so we'll call this stock viewer Microsoft. And then we can choose compatibility modes, which are really nothing more than a whole set of fixes that have been bundled together to cause some operating system compatibility, just making it easier to apply a set of fixes to the app rather than you having to figure out individually which fixes are needed. In this case, though, I'll skip over those and see the complete list of individual fixes, all 398 of them. And then from there, I would have to figure out, well, based on the behavior that I'm seeing with this application, what fix needs to be applied. So first of all, I guess it's useful to launch that app and see what it's going to do. Comes up with an error message. The error message says you must be an administrator to run this application. Written in the XP days, it assumes that everyone has admin rights and complains if you don't. But through the App Compat Toolkit, there is a force admin access shim, which causes the operating system to lie to the app. If the app asks the operating system, am I running with admin rights? The operating system says, yes, you are, even though you're not. So in this case, that's all that's needed to fix that one particular problem. We have the shim here now. I can save that App Compat database. We'll call this one MMS. Oh, I have to tell it where to put it. Call that MMS. So it's now saved. Once it's saved, I can install it. It's now been installed and it's active on the machine. So saving it actually creates an SDB file. If we look in the Documents folder where I saved it, we can see the mms.sdb. So it's a security database that contains the shim information. And then when I said to install it, it runs sdb inst, which is a command line utility that's present in every OS that we've shipped for the last, 10, 15 years. So once that's installed, that shim's active, and now when the application launches, those shims are automatically applied to the app's behaviors. So now when I click on that app again, it comes up without displaying an error message. So depending on the types of issues that you're encountering, this might be all that's necessary. You may be able to go into the compatibility administrator and figure out, for the problem that I'm seeing, are there any shims that can be applied to help with that? Now, there is a bit of a learning curve that goes along with this tool because you have to figure out what those 398 different shims are, but you can also look then at those groupings, like make it behave like it was Windows XP, to see if that's an easier way to fix the application. We have lots of consultants who go around the world and basically live in this tool and use it to fix applications one at a time by going through and figuring out what's the bad behavior that they're doing, how can we fix that with the shim. Some of these shims are simple, like in this case, lie to the app, tell it that it's running with admin rights. Others can get a little more complicated. There are shims that allow you to redirect file access. So maybe you have an app that was hard-coded to look for C:\WinNT. Well, guess what? Windows 7, Windows 8 don't install in that location. They always install in C:\Windows. So you can apply a shim that says automatically redirect any file access to CWinNT to go to CWindows instead. You can even go further and say, well, maybe I can't get rid of that pop-up error dialog, but I can apply a shim that says automatically click OK when it shows up. So you can suppress errors so that the user doesn't even see them. Lots of options on how you can apply shims to fix applications. So it's worth playing with. It's good to help address any application compatibility issues that you might encounter. Next on the list is another tool inside of the App Compat Toolkit called the Standard User Analyzer. This one is, well, it's kind of good in theory. The idea is that you run this Standard User Analyzer, tell it to run an app, it watches the app and then sees what it does wrong. And based on what it does wrong, it offers suggestions on the shims that you need to apply to have it run right. In reality, though, it doesn't always figure out what's really wrong. So let's run through a quick test just to show you what I mean by that. So we have sua.exe. sua.exe is the command line utility, or actually it's a GUI utility, where you can select an application and tell it to run another app and watch what it's doing. So I could browse to that same, let's select stock viewer control panel. Run that one instead. We can say to launch it. It'll go ahead and run it. It can do whatever it wants. In this case, there's only one option. We can exit out of it. It'll then analyze what that app did and suggest any errors that it ran into. And then based on those errors, you could say to apply mitigations. So by applying mitigations, it can create the shims to try to address that. In this case, it's saying that there are some shims related to local mapped objects that would be applicable to this particular application. So if I clicked apply, it would go ahead and take care of that. Now, in a lot of cases, it will come up with false positives. It'll tell you things or problems that really aren't, because applications in a lot of cases attempt to do things, and when they don't work, the app still works. They just assume that, oh, I can't do that, and I'll continue on using some other mechanism. But just be careful with this one, because it doesn't always give you the exact right answer to fix the particular app. There is another tool out there that isn't part of the ADK called LUA Buglight, which takes a different approach to solving the same problem, and it has a lot less false positives, so you might want to take a look at that one. That one was created by one of the MCS consultants, Aaron Margosas. It tries to do a smarter way of analyzing things, so it can run an application without elevating it, allow it to attempt a particular operation. If that operation fails, then it will elevate that operation and check it again to see if it succeeds while it's elevated. That way it can compare the results between those two and be able to say that, oh yeah, this app is going to break because it tried to do this and it couldn't succeed unless it was elevated. So a little better tool in some scenarios to look at. Next tool in the list kind of shifts us into the deployment tools category. These deployment tools are just really assorted. Some of them do, well, they're only loosely bundled together. So in this case, the first one of those in the list is BCD boot. So let me start off with BCD boot /?. Like most of the tools, we can get help and it'll show us details on what BCD boot is enabling you to do. But basically, BCD boot is needed to create a new entry in the BCD file. So why would you ever want to do that? Well, if you're installing an operating system using Config Manager, using MDT, it takes care of this for you. So behind the scenes, it runs BCD boot or the equivalent API or WMI calls. But if you're going to set up an operating system yourself by doing something like an ImageX apply of the OS, you can then use BCD boot to create the BCD entry that's necessary to boot that operating system. Okay, but when do you normally do this by hand? Well, let's say you deployed an operating system using MDT. So you have a machine that's running, say, Windows 7. And now you want to run Windows 8 on that same computer. Using boot from VHD, you can copy a VHD file of Windows 8 onto the same computer as the Windows 7 OS, and then run BCD boot to add a new entry to the BCD pointing to that VHD file, and then have a dual boot system, where your existing Windows 7 OS is still completely intact, running from the hard drive, and the Windows 8 is sitting in the VHD file, so you can boot back and forth and they don't mess with each other, and makes it easy to test out new operating systems that way. You can create a BCD entry completely from scratch using another tool, BCD Edit, but it's really tedious because there are about 15 different entries in a default BCD entry that you have to create one at a time. By using BCD boot, you just point at the operating system and it creates all that for you. So we can specify in the example here, it says to run BCD boot, and then the path to the operating system. In this case, I'm going to specify vWindows, and I can specify add last. So in this case, what is V? Well, if we look in disk part, list volumes, V is a small file, a small disk, that's actually a VHD that I've mounted. And it contains a copy of Windows PE, just because it's faster to mount and easier to create an entry for that. So when we ran the command, it said, warning, I couldn't find some of the things that I was looking for. If this was Windows PE, ignore this error message. But it created a new BCD entry for that VHD file. So now if we do BCD edit /enum, we can see two different entries. One for this V partition and one for our current Windows Server 2012 operating system. So it easily created the entries for boot for VHD, but it had no clue that what it created those entries for was a VHD. So it ended up creating the entries wrong. It ended up saying that I want you to boot this operating system from a partition that's currently labeled with drive letter V. But that's a VHD that's temporarily been mounted. So if you were to try to reboot and actually choose this option, it wouldn't work. But fortunately, it did most of the rest of the work for you. You just need to fix it to specify the path to the VHD. So first of all, I need the identifier. In this case, I actually made it the default one on this operating system in this BCD. So I can do BCD edit /set, and then the entry that I want to change, which is default in this case. And then I can specify OS device. What is the syntax? VHD equals, then a bracket, C:, bracket, /temp.vhd. So in this case, I need to specify that this is a VHD boot entry, that it exists on what's currently labeled the C drive. When the machine reboots, it loses all track of that, so that's where those brackets come in. It basically means substitute in the volume ID of the C drive. And then the VHD is in the temp folder, and it's called temp.vhd. So there's one entry for OS device. There's a second entry for device. We had to change both of them the same way. And now if we do BCD edit /enum again, we'll see those two entries have been changed to the proper format for boot from VHD. So if we mark that one, that would be the proper way of specifying a boot entry that boots from the VHD file. So BCD boot does the heavy lifting for you, although it messes up these two entries, and BCD edit will then let you easily fix those two. In this case, I don't want to leave my operating system set to boot from this VHD file, so I can use BCD edit, which we've been using as we've gone through here, to delete that entry. So if I do BCD edit, delete, default, we just deleted the new one that we added. Now when we do enum, the default is again the current one, and it's cleaned up that additional one that we added. So fairly easy to clean things up if you didn't do something correctly. So BCD boot is useful for creating new boot entries from scratch. BCD edit's useful for changing individual settings, for deleting, for enumerating to see what else is in BCD. It's not something that you'll use frequently, but it does have some uses. Maybe you're moving drives between systems and you need to set the detect HAL flag. Maybe you want to turn off the NX checking that the operating system's performing because you're testing out drivers or something like that. So there are a variety of different ways or different reasons that you would want to run BCD edit to tweak settings, but for the most part, the deployment tools generally will just leverage these tools on your behalf to take care of any deployment work that needs to be done. Bootsect is another tool. It's kind of in that similar vein of things that are normally executed for you automatically that you will probably never need to execute by hand. One of the main reasons why you would never want to execute this by hand is Let's say you have a machine that you're going to deploy a new operating system to. It doesn't have any OS on it right now. Maybe you got a new hard drive out of the box, you plugged it into the machine, you're booting up, there's just nothing there. Well, when you do a bare metal deployment using MDT, Config Manager, WDS, doesn't matter what it is, it's going to run diskpart and clean that disk. The process of running diskpart clean does the equivalent of bootsect. It installs a Windows Vista or later version of the boot code that's needed to load a Windows operating system. So diskpart clean takes care of that. So when is bootsect even used then? It's used in scenarios where you have an older operating system, something older than Windows Vista, and you want to be able to boot a newer operating system. So let's say you're running Windows XP. Windows XP would have a boot sector that knows to look for NTLDR. That's the name of the bootloader file. Windows Vista and above use boot MGR, different file. So we need to install a new boot sector using bootsect so that it knows how to boot the newer operating system. So both MDT and Config Manager will automatically run bootsec.exe to install a Windows 6.0 boot sector anytime you're refreshing from Windows XP to a later operating system. I mean, it's harmless to run it. I can run bootsect here. /? Shows me what the options are. NT6.0 installs the Vista or later version, so it looks for boot MGR. If you do NT5.2, then it installs the XP boot sector, which will just look for NTLDR. So normally you would just specify NT6.0 all or NT6.0 sys, and it will update the file system boot code on that particular volume so that it will now have the right boot sector in place. Simple tool. There is an MBR switch in here as well, which actually was added after the Windows Vista release. You would have to be in some really strange scenarios to use that switch. There might be someone in the room who's done that before. That one's primarily useful in cases where your operating system started off as Windows 2000, and now you're trying to get it to the same hardware to run Windows 7. Well, in that case, you need to also specify /MBR to get it to update the master boot record as well as the boot sector. I hope most of you aren't running machines that are still running Windows 2000, so you never had to worry about that switch. But we've had escalations where I've been up at 2 in the morning dealing with customers in Europe who have been trying to do that. And as a result, there's now a new /MBR switch on this tool. So just in case that ever happens again, it doesn't cause us lost sleep. Next tool on the list is one that we could spend an entire day talking about because it just keeps getting bigger. DISM. DISM is kind of the future for all Microsoft deployment configuration tools. Rather than having different command line utilities for everything you need to do, everything will end up in DISM or in the DISM PowerShell commandlets as things continue to move toward PowerShell. DISM has lots of options. If we do DISM /?, we can see the top level options. And there are quite a few of those. Oops. Helps if I don't scroll quite so quickly. So there are options there for creating images, so dealing with WIM files or VHD files, listing out images, mounting them, unmounting them, inspecting the operating system, so looking at the features and roles that are installed on the OS. But to get deeper into it, we had to specify what we want to act on. So if I do DISM /online/?, it'll show me all the options that are applicable to the current running operating system, where then we get a whole bunch of new items that are supported, including items related to package servicing, related to apps, so these would be app patches, the international settings, locale settings, anything related to that, injecting drivers, removing drivers, querying drivers, applying unattends, provisioning new Windows Store apps, all kinds of capabilities tied into this DISM tool, including also being able to change the edition of the operating system, which only works from a few different SKUs. So maybe you bought a machine that has Windows 8, the standard SKU, and you wanted to upgrade it to Pro. You can actually run a single DISM command, and it will convert one to the other if you give it a new product key. So all the magic that would generally happen through deployment tools or different control panels are all tied into this tool. So just to give you an example of some of the things that we could do, I could do dism/get wim info and then specify a wim file. Let me see if I can find a operating system here. Operating systems, Windows 8, sources, install.wim, and get information about the images that are in that WIM. In this case, there's only one. It's Windows 8 Enterprise. It knows the size of it. So you can do simple things like that with images. You can do similar things with VHDs. Where it gets more interesting, though, are when you start talking about really servicing the OS. So if I do /online/cleanup image /start component cleanup, that will actually go through and remove any superseded components that are in the operating system. So as you're going through each of the Patch Tuesdays and installing updates, those updates always update existing inbox components in Windows. The old versions, though, aren't deleted, just in case you ever wanted to roll back by uninstalling those security updates. If you run this command, online cleanup image start component cleanup, it will physically remove those older versions. So at that point, you can't roll back, but the benefit is you free up the disk space because you don't have to worry about this anymore. So this is the type of command that I'll routinely put into a task sequence used to create an operating system image to make sure I get rid of the garbage that I don't really want to be on every machine. So that's useful for doing that type of cleanup. Now, when I run it the first time, it will take a little bit, and then it'll say, yeah, you need to go ahead and restart Windows in order to physically delete those, but it's easy enough to do. It's just not something I'm going to do right now. There are also commands related to roles and features. So if I do /online/get Windows features, oops. And I always forget what these command line options are because they're just way too obscure in some case. It's not Windows features, it's just features. So that's the hardest part with this tool, is just remembering what the commands are. In this case, we can see all the features that are present in the operating system and whether they're enabled or disabled. So let's see if there's something I don't mind turning on this machine. So there's a TIFF-I filter so that Windows can automatically index TIFF files. I don't know why you would ever want to do that, but TIFF-I filter is the name of the feature. I can install that by saying enable feature. Feature name, TIFF-I filter. So simple enough to run. It's enabled the feature. It's now part of the OS. It's saying, well, you need to reboot in order to actually activate this. No, I'll do that later. So those are the types of things, like if you've used the Microsoft Deployment Toolkit, it has an install roles and features step where you check off all the different things that you want. All it's doing is generating these DISM command lines for you to install whatever roles and features you want on the OS. You can do that yourself, either through the operating system deployment process or, in this case, for running OS later. So definitely study up on all the different options that DISM has available to you. There are quite a few of them. Figuring out all the command line options, just printing out all of the help screens can take up quite a bit of paper just to explore it and figure out what types of things might be useful for you. DISM also can be used for creating and really customizing Windows PE images as well. So if you're getting deeper into creating your own Windows PE boot images, you would be forced into using DISM for that as well. So definitely lots of opportunities for trying to figure out how this one works. Next one is simpler in concept, but it has just as many command line options. OSCD image. The tool's purpose is to create an ISO file. So take a folder containing files and turn it into an ISO, which we need all the time as we're creating ISOs that you want to be able to burn to a CD or a DVD to boot the machine up to do a bare metal deployment. But it can also be useful in just simple virtualization scenarios. You want to move files into a VM. Well, maybe you've got the networking set up so that from your VM you can map a drive out to a server and copy files in that way. But in a lot of cases, it's easier to just create an ISO and then mount that ISO into the VM. So you can use OSCD image, which has screen after screen after screen of help files, help screens, help settings. So if I want help, I have to specify help ISO, and it'll show me the options that are generally used to create an ISO. But at the bare minimum, all I need to do is run OSCD image and then a path to the files that I want to turn into an ISO, and then the path to the ISO itself. And it gives me some warnings saying, oh, you can't do this because you didn't specify a command line option to allow for long file names. That's one of these options, -n. So I have to specify -n here. And I might as well specify the other one that I can see at the top of the screen, -d, so that it will keep the upper and lowercase file names. Otherwise, it converts everything to uppercase. So I can do that, and it will quickly compress all of those files into an ISO file. So if we look at ctemp, we can see there I now have my MMS.iso file. Not a very big one, which is why it got created fairly quickly. Now, I could take that, copy it to my virtual machine server, and mount it into a virtual machine. That's useful, but also, if you're running Windows 8 or Windows Server 2012, we finally built in the ability to mount ISOs. So I can actually just right-click on that and say Mount. And we see it show up here with a new drive letter. This is the F drive containing all the files that I just turned into that. When I'm done with it, all I had to do is right-click again and say Eject, and it goes away. So really easy to deal with both ISO files and VHD files in Windows 8 and Server 2012 because we finally built support for dealing with those into the Explorer shell. So with OSCD image, that's the bare minimum, the simplest possible example. But if you were to look at Config Manager or MDT, something that's creating a bootable ISO, especially a bootable ISO that needs to run on UEFI and non-UEFI computers, the command line that it tends to end up generating is much, much bigger. I think I have an example here. Let me see if I can find that one. Windows Kits 8.0, Assessment and Deployment Kit, Deployment Tools. There it is, bootable.cmd. So this is the type of command that MDT would generate, which is useful if we wrap it. So it basically says, I want to create a new ISO. That part's obvious. U2 just says what level of UDF file system support it wants, and then it gives the specific version number 1.02. -m, I don't even remember what -m means. -o says go ahead and overwrite. -h says something about it can exceed the normal size for a CD. W4, all of these options do something different, and all of them are really necessary to get a properly booting operating system installation CD. You never had to worry about what these are, though, in most cases, because the tools will take care of doing it for you. And some of these are just really kind of obscure. Like it's necessary to order the files in a certain way on the ISO in order to get the Windows PE to boot on some machines, so we had to specify the order of the files to get the boot files at the beginning of the CD and everything else at the end. We had to specify 2 different boot sectors. One here, ETFS boot, in order to boot the machine on a non-UEFI computer, and then a second boot sector to boot it on a UEFI computer. Then again, we specify the source. In this case, point me at the Windows 8 Enterprise x64 source files, and then the new ISO that I wanted to create. So why would you ever want to do something like this? Well, imagine that you've got your Windows 8 media, and all you want to do is install it using an answer file. So by default, you could use the media and a USB key, but maybe you just want to put those together onto one new CD. So you can drop a new unattend.xml into that folder that you're using as the source, burn it as a new ISO, burn it to a new DVD, and then when you install from that DVD, it'll process the unattend and not ask you any questions. So fairly easy to do if you know all the different options to get it to behave exactly like the original Windows 8 media would. Okay, that's OSCD image. WDS MCAST is the next tool in the list. This one ties in with Windows Deployment Services, which serves 2 different purposes. One is to perform PXE booting. The other is multicast. Those can both exist independently of each other. So you can install WDS and say, I only want to do multicast, or install it and say, I only want to do PXE, or you can do both. But in this case, we can use it to transfer any files. So we can set up on the server the files that we want to share out via multicast, and then on the client side, we can actually transfer those over. So first of all, let's look at Windows Deployment Services here, where I can see the multicast namespace that I've set up on this particular server. I've shared out an entire folder. This folder is called Source. And if we look on the server, it's actually out here on the E drive. It's this folder, E:\source, which contains a whole bunch of stuff. It contains ISO files and MSIs and anything else. Any of the files that are there, I can now transfer using multicast. But only from Windows PE, because WDS only supports multicast in Windows PE. So I've got that set up. It's set up as autocast, which means wait for a client to ask for the content and then start sending it, and keep sending it as long as any client is interested in receiving it, but in a round-robin fashion. So it just keeps sending start to finish in a loop until all the clients are satisfied. So if one client starts in now and gets halfway through the file, and then another client starts in, both clients will get the second half of the file, and then that second client will wrap back around and fill up the first part that it missed from before. So really easy to do multicast compared to some of the previous implementations for that. On the client side, if we look at the virtual machine here, the command line to do that is something that I'm not going to even try to type in. I typed it in earlier and saved it here so I could just hit enter. But basically I need to specify WDS MCAST and then the name of the server. So Contoso MGMT is my server. The username that I want to connect with. I always use my administrator account. The name of that namespace, which is source. I want to transfer a file with progress, with verbose messages. The source file relative to that source namespace is Contoso x86.iso, and the destination should be placed at C:\test.iso. So when I run that, it'll prompt me for a password, which I could put on the command line, but it's just as easy to type in here. And it'll then begin doing the multicast transfer. Now I could then go to a second machine and repeat that same command, and it would join into this multicast session. I could add hundreds of machines into this multicast session so that they all receive this file at one time. That's really the scenario that you would want to use multicast in. Imagine you're deploying a 5 gig operating system image to 200 machines at one time. Without using multicast, you would need to have a significant network in order to do that number of machines at once because of just the bulk of the data that you're moving around. But with multicast, 200 machines at one time, it's just one stream of data that's being sent across your network. So very scalable as far as multicast network impact goes. MDT will use WDS MCAS, the command line, as part of a light touch deployment. Configuration Manager actually uses the APIs that are provided to do this same thing. So if you're using either of those deployment tools with WDS, with multicast enabled, this is basically what's going on behind the scenes. It's just the actual implementation will vary depending on the OS. That's a fairly good sized file, so it's just going to continue displaying the dots to show that it's making progress. We can come back later if we have time to see if it finishes, but it should finish without any issues. Oh, and then I just lost my network connection. So the internet connection has been rather flaky today, as you probably noticed in the keynote. And unfortunately, most of my demos are on the other end of it. So we'll see if it comes back here for a few seconds. In the meantime, let me see if I can get to a different connection. Okay, hopefully it'll connect here. It says I have a connection. All right, let's give it a minute. While it's working on that one, let me bring up a command prompt here. Oh, now it's going to come back. Never fails. Except it generated an error because I've got another session over here. Okay. So, next in the list. Scan state. Now we're talking about the user state migration tool, USMT. USMT contains 3 command line executables. One is scan state.exe, which is used to capture user state. There's a second one then called load state that's used to restore what scan state is captured. And then there's a third one that's more of a utility executable, USMT utils, that's used to do a few different things. With the latest version of USMT, it can do more than it used to be able to. It was only used to remove a hard link state store folder, which is really hard to do manually if you've ever tried to clean up after the scan state execution, because it has all kinds of security challenges on the files that are present, and this utility would just obliterate the folder and take care of that for you. But in the latest version, they've also added the ability to extract individual files from a state store and also verify a state store to make sure that it's structurally sound. So some of the things that you needed to contact Microsoft support for before, you can now take care of yourself just by using USMT utils. So that's a useful tool. Now, in the case of USMT, you would think that I could just go onto my server here, go into the user state migration tool folder, AMD64, run scan states / and be able to at least show you the command line options that are available. But no, it says USMT does not support Windows Server operating systems, which is true. It doesn't support capturing and restoring user state from a server. It only supports it from a client. But That's not very nice. It won't even give you a help screen unless you're on the supported operating system. So we need to switch over to a supported operating system, which I have a client machine here. I can bring up a command prompt, which I will run as an administrator. And from here, well, first I need to get to the right folder. Probably helps to come up with a font that you can actually see. So then we can run scan state /?, and don't do it with piped into more because you end up with something that looks like this, which isn't very useful. But /?, we can see all of the available command line options, and again, these tools are run for you, so you probably don't need to memorize these, but to test things out, usually it's useful to know at least the basics. So we need to specify scan state, and then we need to tell it where. So let's just use /temp store. /C says continue on non-critical errors. /O says to overwrite if it's already there. /I allows us to specify what we want to migrate. Which I think I can just say MIG. Let's just do MIG app.xml. And I think that's enough. Generally, you would also specify command line options to say /hardlink, /no-compress, /EFS hardlink, /L for logging. You can tell it where to write its log files, /progress, or it's just an endless series of options that you can specify here. But this should be enough to get application settings from this particular machine, which won't take very long because I don't think there are many apps on this machine. It'll examine the system, it'll figure out what's there, and based on what it's found, it'll go ahead and do the migration. So this would be done on the old computer to capture the user state, or on the old operating system if you're going to do a wipe and load. After that's finished, you would then go to the new computer or the new operating system and run load state to restore the user state, pointing at that same state store folder that I created. I'm creating it in this case on this computer itself, on this operating system, which might be okay if I'm doing an in-place refresh, but if I were doing a computer replacement, I would need to copy that folder off onto another computer so that I could access it from that other machine. So in this case, it says, okay, everything's been migrated. Because I specified /C, there were some non-fatal errors that went through. It went ahead and told me about those. It set a return code to indicate that there were errors. So this utility is all about being run as part of an operating system migration tool. So generally you wouldn't run this manually, but certainly can. And then to reverse that, I would specify load state, again specifying the state store. I don't need to specify /C. There's nothing to overwrite, so that one doesn't apply there. I still do need to specify the XML file that declares what I want to migrate. And I think it'll pretty much figure out the rest itself. Generally, you wouldn't do this on a running operating system. You would only do this on a new operating system, but in this case, it's telling me that it couldn't access that because I do actually need to specify /hardlink /no-compress. And then it will restore the data right back over the same location that it captured it from. So easy enough. Tools are, most of the time that you would spend on USMT isn't going to be running these command lines, it's going to be customizing those XML files. The XML files that are provided by default know how to migrate Windows settings, they know how to migrate Office settings, they know how to migrate user data, documents. But if there are any other custom apps that you would want the settings to be migrated for, you would have to create the custom XML manifests that tell USMT where are the registry keys, where are the files that need to be migrated, where do they need to be put on the new operating system so that the app would then continue to work. And then the last one, USMT utils. We can see the options that are available there, including the new ones, the /extract, /decrypt. The main one that we want to do here is the cleanup. So we can do /rd, and then the path that we specified before, and /y to silently clean up. And it gave me a return code 35 to tell me that in order to complete the removal, I need to reboot the computer, which is fine. Some of the files, because they're hard linked to a real file that exists on the system that's in use, the hard link can't even be deleted without rebooting the operating system. So that's basically what's happening there. So you would have to, if you scripted something like that, you would have to expect a return code 35 to indicate that that's what's going on. Okay, next one on the list. Windows PE. Windows PE, seems like I missed one in there. Nope. So Windows PE, you can create your own custom image, your own custom Windows PE boot image, and what's provided for you to do that are batch files. So if we go up a couple of levels here and go down into Windows pre-installation environment, you can see the 3 batch files here: copype.cmd, makewinpemedia.cmd, setsanpolicy.cmd. Those are the files that you would use to create your own custom Windows PE image. So what you would generally start with is copype. If we run it without any command line options, it'll ask us, do we want to do it for AMD, x86, or ARM? But since you don't have the ARM files, that one would never work. So we can do copy PE, AMD 64 to create a 64-bit image, and then we can specify where we want to put it. So I'll say MMS PE. It will copy all the files necessary to form kind of that initial structure of the boot image. So if we look at that folder, it created a media folder that's really where it's going to end up putting an ISO. It creates a mount folder where it's taken the WIM file that it uses as a starting point and mounted it, and any other files that would end up getting added would be placed into this folder structure. So generally then you would run dism to add and remove any optional components that you wanted. Then you would dismount those different pieces and create media out of it. Now the makewinpe media.cmd, that one will take care of a lot of that for you. So I can actually say that I want to create a UFD, a flash drive, or I can create an ISO from ctemp MMS PE, and I want the ISO name to be ctemp MMSPE.ISO. And it'll take care of all the rest of the steps necessary to do that. So, yeah, the batch files will take care of the kind of the housekeeping parts of that by copying all the files into the needed place as your starting point. It'll also then take the folder and turn it into an ISO for you, but all the work that goes on in between, where you add the optional components, your own scripts, your own executables, you would have to do that part yourself. Fortunately, the deployment tools that we have, MDT, Config Manager, all of the rest of them will handle this process for you automatically so that you don't need to get into these batch files in order to create these boot images. But if you wanted to, they're available here and they'll take care of that for you. Next on the list, the Windows Performance Toolkit is surprisingly useful because it allows you to troubleshoot slowness of your Windows operating system. So let's say you've deployed Windows and it seems to be taking longer and longer after a reboot before you can actually log in or before the machine's usable, and you want to know what's happening during that time. The Windows Performance Toolkit makes it fairly easy for you to capture a trace of that. And maybe that trace isn't something that you completely understand, but it's something that you could send to your support contact inside of Microsoft, whether that's a TAM or a PFE or just a standard support call, and they could analyze that and tell you what's going on. So if I switch back over to this client machine, I can open up the command prompt for deployment tools, which I should have done elevated. Hate when that happens. Get me to the corner. So I run this elevated. And now I think I need to go up a level. Up another level into the Windows Performance Toolkit. From there, I can run xbootmgr.exe/?, so it'll show me what options are available. The basic option I want in this case is -trace boot. So -trace boot says, I want to run a trace as this computer reboots to figure out what's taking so long during this reboot cycle. So it will automatically reboot the machine, log me off, restart the computer, but as soon as the operating system comes back up, it'll start capturing trace information. That trace information will record everything imaginable about the startup process. What drivers were loaded, how long did those take, what services were started, how long did that take, what processes were running, how long did each one take to start, what did it do, how much I/O did it generate, how much memory did it consume. All of that is captured into these trace files and then can be analyzed using the corresponding Windows Performance Analyzer tool after the reboot has completed. Unfortunately, we used this same virtual machine to perform some servicing operations, like that cleanup operation and the installation of the TIFF-I filter, so it's taking a little bit longer to reboot because it's taking care of that. But as soon as it comes back up, we can then see another message on the screen saying that it's just waiting for 2 minutes for the system to calm down. So it waits until the machine logs back in, and then wants to keep running for another 2 minutes, because you've probably noticed that just because you can log in, that doesn't mean Windows is necessarily done loading stuff in the background and fully functional. So by waiting that extra 2 minutes, you can capture anything else that's going on. So it's useful because it can really let you drill in, especially if you're having challenges around group policy processing or startup scripts, and you're trying to figure out why it's taking so long. Our premier field engineers will use this tool fairly heavily anytime you call them in to help out with any performance issues. They can generally run this and within an hour or so be able to figure out, well, what's going on with this system? Why is it taking so long? They'll point you at the individual script that you could be running. So you could see a process in here that runs, say, wscript.exe, which is your startup script being executed, and see that, oh, it started at this time and it took 2 minutes before it finished. What are you doing in your startup script? Let's open up that script and figure out what's going on. So very nice to be able to drill in and see during the long periods of time where the system doesn't appear to be doing anything, what is it really doing behind the scenes? So we'll give that a minute to come back. Since we're running out of time here, we're down to the last 2 minutes. Let me jump over to the Windows Assessment Toolkit, and then we'll quickly come back to this one, if I didn't just lose my internet connection again. Yep. Okay, we'll wait. So the last one in the list, if we can get to it, if we can't, we'll see what happens, but is the Windows Assessment Toolkit. The Windows Assessment Toolkit is a framework that lets you run a set of assessments, where an assessment is really nothing but a script or an executable or something that generates an XML output file. And that XML output file is specially structured to be able to report back into the tool to tell it here are the number of errors that were generated, here are the number of warnings, here's any informational messages that you need to know. So it's all about being able to run a whole set of assessments against a computer, gather the results, and quickly display you those results. This is our previous one where the performance trace is now finishing up, so it's saying I'm going to continue to wait for 120 seconds. If you know the system's already calmed down and it's done doing its thing, you can go ahead and click Finish. Then it will run the performance analyzer where we can actually look at the trace. So it'll stop the trace. Tells us that the trace was written to Windows Kits 8.0, Windows Performance Toolkit, boot base, etc. And we can run the Windows Assessment, Windows Performance Analyzer. From there, we can open that trace file. And this is really where the skill comes in, because, I mean, it's one thing to have the trace, it's another thing to understand what the trace is telling you. But it loads up the trace, and from there you can add graphs where it will show you all of the activity that was going on the system. When we look at the process activity, we can see the different phases of the boot, we can see the events being generated, we can see the process details. It's easy enough to add those into the picture here, where we can then visually look to see, well, what was taking the longest during that boot process. As we scroll back and forth, we could see that, yeah, some of these are obviously taking longer than others. We can see how much activity they had generated, how many different points they had generated, what images were loaded inside of it. So really this becomes the point where you need to spend time figuring out, well, what does all this mean? And being able to drill in is the key part of using this tool effectively. Definitely a learning curve that goes along with this one, but it is a very nice tool. It's written very well, very easy to navigate through large amounts of trace data without needing to dig into the details of how all of these traces actually work. So the last one on the list, we'll bring it up real quick here, is the Windows Assessment Toolkit, which again I had to do that on the client machine because it's not present on servers. So Windows Assessment Client, Windows Assessment Console. So the Windows Assessment Console is the one that's tied to the toolkit. It has a number of pre-configured jobs, where a job is nothing more than a group of assessments. It also has a bunch of individual assessments. So in this case, I could say I wanted to run an individual assessment. Maybe I just want to see, I don't know, maybe the equivalent of WinSat. I can run an assessment that runs WinSat and gathers the results from that. So this one's all about these pre-packaged assessments. As soon as I click Start, it'll go ahead and run that, gather the results at the end, and then display those results visually for me. So it can be useful to run these. It's fairly easy to create your own assessments as well. All they have to do is generate an XML output file that's formatted appropriately for this tool to read it back in. Easy to do, easy to add your own custom errors and warnings into this. In this case, it ran through, generated 2 errors. We can drill in and see what those errors are. One is it tried to write back to a network path and couldn't find it, couldn't succeed. So just the particular test I told it to run, it wasn't able to do what it wanted, and it didn't know where to write it anyway, because that would generally be configured as part of a job. But it's a useful framework for running your own tests, and the canned ones are really what get tied into that OEM certification process. might be something you want to play with, but it generally does require more of a lab environment to use that with. So that's it. We went through every single tool except for Windows Assessment Services, because that would require bringing a whole pallet full of equipment in here, and I didn't quite want to do that one. But it's really just kind of the extended version of what we just looked at with the Windows Assessment Toolkit. It's the complete automation around being able to push out images, to be able to run assessment tests, gather all the results together, compare them, and really dig into the details about a whole lab full of computer performance, operating system performance. So that is the ADK in a nutshell. There are lots of different tools, and a lot of them don't really even have a whole lot in common. I mean, they're just really all over the place as far as tools go, but they're all related to Windows deployment in some way. They're all consumed by most of our deployment tools, so you will be downloading and installing the ADK yourself. Whether you ever get into the command lines and the different tools that we looked at today, it just depends on what you're doing. But hopefully this is a decent overview of what tools are out there and what they can and can't do for you. So that is it. Please fill out your evaluations. Tell me if it's worth doing this session ever again, because this is the first time we've done it in public. I'm hoping that you say no, because then I won't have to do it again. But still give me good scores so they don't yell at me for giving a bad session. But thanks for coming, and hopefully that was useful for you.